circle. So our position vector, we can write this equation, R is equal to R magnitude and R unit vector. Magnitude of the R is equal to a radius here. So R unit vector is equal to R position vector divided by magnitude of the R. Magnitude of the R is the radius. Now putting the value of unit vector R, यहाँ पे unit vector R की value put कर लें. So centripetal acceleration AC is equal to V square divided by R. So R position vector divided by R. So centripetal acceleration is equal to V square divided by R square, and this is the position vector. तो एक फॉर्म हमारे पास सेंटीपीटल एक्सेलरेशन का ये भी आ जाता है. So this is the centripetal acceleration. Now centripetal force. According to Newton's second law of motion, F is equal to ma. This centripetal force changes the direction of the velocity of the body at every point along the circular path. So we can apply the Newton's second law of motion. So centripetal force is equal to ma. This acceleration must be the centripetal acceleration. So putting the value of A here, centripetal acceleration के value put कर लें, तो Fc is equal to m v square divided by r. So this is the magnitude of the centripetal acceleration, centripetal force. Magnitude of centripetal force. अब centripetal force is also a vector quantity. Its direction is always towards the center of the circle. So in vector form, we can write the centripetal force in vector form. Of the centripetal force. So centripetal force is equal to m v square divided by r in terms of unit vector. तो एक फॉर्म हमारे पास ये आ जाएगा, direction of the centripetal force in terms of unit vector. This unit vector यहाँ पे we will put the negative sign. Negative sign shows that towards the center of the circle. यहाँ पे भी negative sign हम put करेंगे, which is towards the center of the circle. अब इसकी जगह अगर हम put कर लें, यानी as our unit vector is equal to our position vector divided by r. तो यहाँ पे ये value put कर लें, तो centripetal force is equal to minus m v square divided by r square, r unit position vector. So this is the another form of the centripetal force. Okay. We can write this centripetal acceleration and centripetal force in another form also. So we can write these equations according to, as we know, V is equal to r omega. तो पुटिंग द वैल्यू ऑफ v स्क्वायर है, तो सेंट्रीपिटल एक्सेलरेशन आल्सो इक्वल टू माइनस r स्क्वायर ओमेगा स्क्वायर डिवाइड बाय r स्क्वायर और पोजीशन वेक्टर। तो इसको हम कैंसिल करते हैं, तो सेंट्रीपिटल एक्सेलरेशन आल्सो इक्वल टू माइनस ओमेगा स्क्वायर और पोजीशन वेक्टर। तो एक फॉर्म हमारे पास ये भी है, और इसका एक फॉर्म जो है ना हम इस फॉर्म में भी लिख सकते हैं कि सेंट्रीपिटल एक्सेलरेशन आल्सो इक्वल टू माइनस r ओमेगा स्क्वायर r यूनिट वेक्टर। इस फॉर्म में भी हम लिख सकते हैं। सिमिलरली सेंट्रीपिटल फोर्स को भी हम लिख सकते हैं कि सेंट्रीपिटल फोर्स इज इक्वल टू minus putting the value of v square, v is equal to r omega, this is equal to r square omega square divided by r यूनिट वेक्टर, एक r इसके साथ कैंसिल कर लें, तो सेंट्रीपिटल फोर्स is equal to minus omega square r unit vector, or here is r. So this is the centripetal force in terms of angular velocity. Similarly, centripetal force also in terms of position vector minus ये आ जाएगा here is r minus m v square r divided by r square r, here is omega square r position vector. तो centripetal force is equal to minus m r omega square r position vector. So these are the different forms of the centripetal force. So this is the expression for the centripetal force. Here is in terms of position vector.